Alright folks, welcome to the first video on chemistry topics. We're going to start by looking at the phases of matter and what matter is, which hopefully isn't new to you. This should hopefully be somewhat of a review, but we want to take a look at it from a chemistry perspective this time around. I kind of expect that you're a little familiar with some of this stuff, but let's start by asking the question, what is matter? So if you look at all these photos, they all are matter. Everything, realistically, that you encounter, people, animals, trees, mountains, the earth itself, the homes you live in, coral reefs, all of that is matter. The oceans, the air we breathe, all of these things that you can pretty much imagine are matter. Matter is anything that takes up space and has mass. Those are the two key qualifiers that make something matter. Now, what we're using in science in 8th grade is a kinetic theory of matter. The kinetic theory of matter basically says that matter is made up of particles. Those particles are always in motion. So they're always moving around, bumping into each other, colliding, and jiggling, all these tiny, tiny particles. Um, Obviously, you've probably heard of atoms by now, molecules, these kinds of things. Those are really the main particles we're going to be talking about of matter, but we'll get into those structures a little bit later on. So matter comes in a variety of states, and those states include things that are pretty normal that you encounter all the time, and some things that are kind of exotic that we probably won't go into too much. Um, the main states that we care about are solids, liquids, and gases. We're going to talk a little bit about plasma because plasma is way cool. But we're not going to go into too much with the Bose-Einstein condensate. That particular one might have some interesting applications to quantum computing. So some of you may want to go check out some videos on that. We're not going to do too much in our class with it because it's a bit advanced to understand what that is. But basically, solids, liquids, and gases are what you need to worry about. So let's kind of deep dive into those a little bit. So a solid has a fixed shape. Solids don't change their shape at all. There can be outside forces that come in, like we could have the rocks erode over time in this picture. A lot of this is ice, which could melt, so we could change its phase, or we could mechanically come in and break it. But for the most part, solids aren't going to change their shape. Your table is going to be a table in the same shape as your table always was until someone breaks the table. They also have a fixed volume. Your table doesn't suddenly expand to take up more room overnight or less room. The table stays the same. Now, inside, if you were to look down and actually see the particles that make up a table, you'd see that they're vibrating against one another, but not able to move around each other. So the molecules are locked into place and are strongly attracted and bonded to each other. And ultimately, you can't compress them as a result. They're all just stuck together in one configuration. Now, obviously, we want to represent this somehow. And when we do, the most typical way of representing this is as a box of spheres. So you create a cube of spheres and you kind of show that they're jiggling a little bit. That's what those lines ultimately represent. There's some jiggle. There's some vibrational motion occurring, but for the most part, they're all locked into place. So no one's going to jump around or move around. The patterns of the wood on your table don't suddenly change and morph overnight. They stay the same. Liquids, on the other hand, have particles that can slip around one another. So while all the molecules and particles are tightly packed together still, they are able to slip around and slide around. They're not as tight as your solids are. So that gives liquids an indefinite shape. They're going to take the shape of whatever container they're in. In this case, they're taking the shape of a very awesome looking river flowing around the rocks and all these kinds of things. But if those rocks weren't there, it would take a different shape. Okay. Same thing with glasses of water. I could have a tall glass, a short glass. I could have a sports bottle. I'm going to take the shape of whatever that is. So I don't have a definite shape with a liquid. However, the volume stays the same, even if the shape changes. The volume of a liquid doesn't change. So particles here are still bonded together. They're attracted to each other, but these attractions, they're a lot weaker, and that allows for the particles to slip around each other. And another thing is that I can't compress a liquid. I can't push these particles closer together at all. When you're representing that, usually you want to draw some sort of container for them to be in and kind of show that they're taking the shape of their container. You could show with some arrows that one of the particles is slipping around another particle. That's totally fine. Ultimately, the big thing usually is you just kind of draw a glass. You draw a beaker or something like that, and you put a surface level to that, and you draw all the pieces inside. As for gases, gases are very fluid. The particles are moving around super easily. In fact, there's a lot of space between the particles, much more so than either the solids or the liquids. The particles, they're moving freely around each other. They sometimes collide and will bump into each other, but they aren't like attracted to one another the way that you had with solids and liquids. It has an indefinite shape and an indefinite volume. Okay, so a gas could fill a room, or it could fill a very small compressed container. You've probably seen those gas containers, like the big metal ones where they've got like oxygen or something like that in, or an air compressor. You might have heard of those. Those are actually pushing air to particles closer together so that you concentrate all of these gas particles into a tiny space. In the case of an air compressor, often it's like fill a tire or something like that. So yeah, gases are really cool like that. We can compress them. We can give them the shape of whatever we want to put them in. And to represent those, we generally draw them as being far apart. So you can draw some of them colliding. So you see there's a couple of particles that are coming into each other. Sometimes you can draw big arrows to show that they're moving fast and around one another. That's all fine. The big key is to make sure that you draw your particles apart from each other. If you haven't captured the three drawings that I showed, it's really important to go back right now and grab those, because that's probably the most important piece of the puzzle from this particular video. You're going to see a lot of problems where it asks you to draw a representation of a solid, a liquid, or a gas. Okay? So make sure you have these and make sure you understand the concepts of, can I compress them? Can I Do they take the shape of their container? Do they have a definite volume? Do they have a definite shape? So we'll talk about one of the exotics here. This exotic is plasma. Plasma is really cool. Plasma is responsible for some of the prettiest stuff that happens. The aurora borealis is very, very beautiful. If you have a chance, go take a look at a video of that. Um, National Geographic does a few that are really amazing. And ultimately, what you have here is a plasma is a gas that's been heated up beyond the point of becoming a gas. So they keep adding more heat, adding more heat, adding more heat to a gas, and eventually you can create what's called a plasma. And the plasmas have at this point ionized, which we'll get into later, but basically it means that an electron has popped off of these particles. And as a result, you get these amazing visuals that you really don't get anywhere else in nature. So plasmas are really special, very cool. And one of the things that's interesting about plasma is that most of the matter in the universe is plasma, and that's coming out of the stars. So if you think about the entirety of the universe, the vast majority of matter is plasma, which is one of the rarest states here on Earth. So it's kind of cool when you think about just the variety of experiences that you can have when you're thinking about science. Because if we just focused on what we saw on Earth, you wouldn't see too much. You would only mostly see solids. And then we're surrounded by gases. We live in a sea of air, right? And of course, you're probably drinking some liquids. But you would never think that plasma was the most abundant phase of matter that existed. And yet, there it is. Look up at the night sky, see all those stars. All of that is plasma. All right, so let's summarize. Like I said, it's way, way, way important for you to understand how to draw the shapes of the different matters. Um, so solids, again, tightly compressed. We've shown that there's a little bit of vibration between the particles, but everything's going to be like in some sort of a cube. If you really want to draw another shape, you can, but most everyone just draws a cube. Um, Liquids taking the shape of their container. They can slide around. They're moving a little more rapidly. Here in this particular picture, they kind of depict that by showing it with 3 red lines versus the fewer lines in the solid. And then by the time you hit gas, everything's separate. The particles aren't touching. They're moving very rapidly. Here they're showing that with those arrows. They're showing what direction they're moving in and how rapidly they're moving. So this image right here really does summarize a lot of the details that you need to pick up from this video. So make sure that you have this part in your notes, and otherwise you have a great night.